Hello everybody, my name is Hello. Welcome to this video series where we're solving Codeforces problems in Python. We are doing the A to OJ ladder, and in this video we're looking at problem 450A, which is called Jzzhu and Children. I hope I'm pronouncing this name right. If not, just forgive me for the rest of the video. Let's go ahead and see how we're solving this problem. Okay, so let's go ahead and read this question. There are n children in Jzzhu's school. Jzzhu is going to give some candies to them. Let's number all the children from 1 to n. Okay. The I child will at least get A of I candy. So at least A of I candies. Jzzhu asks children to line up. Initially, the ith child stands at the ith place of the line. Okay, so let's say there are 4 children. The line will look something like this: 1, 2, 3, 4. The first child will be standing at the first place of the line. Then Jzzhu starts distribution of these candies. He follows the following algorithm. Give m candies to the first child of the line. If the child hasn't got enough candies, then the child goes to the end of the line, or else the child goes up. Let's say child 1 wants 4 candies because that's the A of I, right? So wants to get at least A of I candies. Let's say child 2 wants 1 candy, child 3 wants 3 candies, and child 4 wants 6 candies. Now what he's saying is, let's say m here is 3. What Jzzhu is going to do is, he's going to give 3 candies to child 1. Child 1 is not satisfied because 4 minus 3 is 1. So he still needs 1 candy. So what that looks like in the second case: 3, 4 and 1. Now 1 will drive 1 more candy, 6, 3 and 1. That's what that will look like. Then again he'll give m candies to the second child. That child is now satisfied because he'll have 3 candies, which is at least greater than 1, right? So this child will just exit out of the queue now. Then he'll give 3 candies to the second child. Third child. In this case, 3 also is the number of candies that they need, so that is also done. In the fourth case, he'll give 3 candies to this child. This child will require 3 more candies at least, so this child will go to the back. So now this will be here and 4 will be here, and 4 will require 3 more candies. Now he'll give 3 more candies to the first child will be satisfied. Then 3 candies to the fourth child will be satisfied. Then everybody here is satisfied. That's it. So anyone who is not satisfied will go back to the end of the queue. That's the question, and that's how this is there until it is empty. Consider all the children in order they go home. Jzzhu wants to know which child will be last in this order. He doesn't want to know the order. He just wants to know who will be last. That's it. Okay. So what the input looks like is, they're going to give you n, the number of children, followed by m, the minimum amount of candies that a child will get for that particular test case, followed by the order in which the children are there. Now, how to solve this question? You guys need to understand this concept here, that this question relies on something where, in case a child does not get the number of candies which is enough to them, they will go to the end of the line. So let me take one case here, and we'll take this case itself. So 1, 3, 1, 4 and 2. Okay, so m is 2 here. See, this child will obviously get more than 1 candy, right? He requires only 1 candy. All of these is A of I's, okay, the number of candies that they need. So when m is 2, he's going to give 2 candies. The child only needs 1, so this is satisfied. This child is not satisfied, sure. This child will be satisfied. This child again won't be satisfied, and this child will also be satisfied. Now the children who will repeat in the second time will be this and this, correct? So we're going to be calculating one thing that's very interesting now. We're going to calculate how many servings does each person need. That is calculated by the number of candies they need divided by this m value right here, correct? Let's say we have 3 candies here, okay, and m is 2. This will give you something like 1.5, but in reality this is 2 servings only. This is not 1.5 servings. You cannot do in decimal numbers. You can either serve them once or twice. So twice is that point where you get at least this number of values. That's why this question says this at least A of I candies. Okay, so this value right here, this A by 2, this will be ceiling of A by 2. Okay, so ceiling of 1.5 is nothing but 2, something like that. Ceiling of 2 will still remain 2. So this is something that is maintained here, which is there in the question. This value right here, let us find. So that will look something like this. So in the first case, this will be 0.5, ceiling of 0.5, comma, ceiling of 3 by 2, ceiling of 1.5, comma, in this particular case it will be again ceiling of 0.5, and then ceiling of 2 followed by ceiling of 1, and this will look like 1, 2, 1, 2 and then 1. Okay, so these are the number of servings that are required for each child. So this child, this child, this child, this child, and this child. Now we need to find out which will be the last child. How do you find that out? See, this order is maintained in every single iteration once it is completely completed. Okay, that means let's say this particular child will go to the back once it is being one turn is over, right? So it'll have one turn left. But you have to note that this child will also go at the end of their turn to the back. That means in every iteration, this order in which they came in will get maintained. Just the number of people who have been satisfied will go away. That's all, right? So now what we'll say is, see, whatever number is highest, right? Obviously that value is going to be the last value, which is that. Let's say this, instead of 1, 2, 1, 2, 1 is something like 1, 3, 1, 2, and 1. That means this child right here needs 3 servings. Rest all only require 1 or 2. That means this will be the last child. True? You are able to understand until now. But what in this particular case, where this value and this value are the same, in that case, keep in mind, since this order is repeating with every iteration, this child right here will be the last one to receive their candy in their particular iteration, because in the second time, this particular child will be the first one to receive their candy, and then only this child will receive their candy. Okay, so how we are going to be solving this question? First, we are going to find out what the number of servings are for every single child. Then we are going to find out the maximum of that child from the back side. So in case there are any repetitions, choose the rightmost one, because the rightmost one will be served the last. Let's say we have a list of 1, 2, 3, 4, something like that, and we need to find the right from here. We are going to be iterating to from the last element to the first element of that list. If we go and find the first maximum from here, we are going to end up with the rightmost maximum. Let's say this is also 4 right here. And if I start from here iterating through all the elements and I find the maximum element, I'll find with this particular value. That will be the rightmost max index. Okay, and how do I find this index? We can use say something like the dot index function. You need to keep in mind the ith child, right? Let's say this is how these are the indexes in Python. But here in the question is given like this is the first child, second child, third child, and fourth child. Okay, so how, in order to find the position of, let's say these are i's, okay, position of the child, this will be nothing but I plus 1. Okay, ith child will have I plus 1 position because indexes start from 0 to n minus 1 and the child indexes start from 1 to I plus 1. That are the positions. Okay, now if you're going to find from the right to the left, how are you going to find this? See, indexes are from 0 to n minus 1, correct? So this value right here, if you're going from the end, this will be n minus 1, the maximum index minus I. Okay, that will give you the list index. To find out the position of the child, you add this plus 1. That you will get as n minus 1 minus I plus 1. This and this will get cancelled. This will be n minus I. This will give you the position of the child. Once you're able to understand this part right here and this part right here, we are able to go ahead with the code. You're able to understand what we've done till now. Go ahead and code this yourself. If not, stick around for the code. Let's just break down the solution over there as well. Firstly, we have to go ahead and take 2 inputs. That will be n and m. So this will be list of map of int comma input dot rstrip dot split. This will give you the values of n and m. Okay, then we have to take a list of space separated integers, and that will be the number of candies. Okay, each child wants. So that will be something like lst is equal to list of map of int comma input dot rstrip dot split. Okay, each child will want a list of I, their particular index. Okay, then what we'll do, we'll go ahead and take the ceiling function of then we need to find the number of servings required for each child. Let's just call this something like servings. Okay, empty list, and we'll do for I in lst, we'll just append servings dot append. Wait, so serve and will be equal to this ceiling function of this value divided by the n, correct? So this value, this will be this particular value divided by m. So that will be I divided by m, but we need to take the ceiling of this as we discussed before, because it's at least that number of candies, right? So we'll go ahead and import math module. So import maths. This is an inbuilt Python module. We'll do something called math.ceil, and in this function we'll pass these values. Okay, then we'll go ahead and append this value into this servings list, and finally we'll have all the number of servings that is required for each particular case. I'll go ahead and print this as well so that you guys know what that looks like. Yeah, you can see these are the number of servings required. In this particular case, see, m is 4, so everybody only requires 1 serving maximum. In the first case, you can see 2 people only require 2 servings, rest all require only 1 servings. In the case is 2, which is 3 and 4. Okay, this is done. We are able to print the servings and we are able to find this particular servings. Then what do we need to do? We need to find the maximum value from the rightmost part. We need its index I. So not only do we need to find this maximum value, we need to find this index of that particular maximum value from the right. In this particular case, it will be from the right, this maximum value 2, and the index of this particular 2, that will be I. Okay, so how do you find this out? We are going to be using 2 list functions. One is called list index, and then another one is called the max function. So let's go ahead and find the max first. Max will be MA, and this will get the okay, so the max function that we are using for a list, let's say this, for example, max of servings. We are doing something like this. This will return the maximum value of that particular element. Okay, this maximum value is we can go ahead and call this something like MA. Okay, now this list dot index is there, right? So that will look something like servings dot index of this MA value. This will give you an index I. But the problem is, if this particular max value repeats multiple times in that particular list, it will look for the leftmost value only. Okay, in this case, if we go from here and we try to find the index of this particular value MA, it will only locate this part, the leftmost MA. Okay, the leftmost maximum value. So what do we need to do? See, I'm telling you, instead of doing it like this, if we reverse the string, if we reverse that particular list, we will go ahead and find the maximum value towards the end. So I'll give you an example of how that looks like. Let's say this is our list, okay? And if we reverse that particular list, so what that will look like is something like 1, 1, 1, 2, 2, and 1 and 2. Oh, 1 and 2, right? From here, if you put that particular max value, you will get this 2, okay? From here, if you try to find the index of the maximum value, which is 2 in this case, it'll say this is that index. But if you do the same thing in this normal servings list, it will say this is the position for me. Okay, so we need to find this value, correct? This, the 2 which is near to the 3 ones, which is here. If we find it from the reverse, then we can use this formula right here, n minus 1, to get the position from the starting itself. That's it. So we have to reverse this string. We have to reverse this list, reversing the list. So there is this function called servings.reverse, that list of reverse. Okay, so there's an inbuilt Python function for this as also. You can just go ahead and put that particular list dot reverse. Okay, you can also list slice from -1 to end and then put the step value as -1. That's up to you. Then once this is done, find out the index I. Okay, this I value will be given as this in, okay, servings dot index of MA. You'll get I, but the answer will be n minus I. Okay, it will not be I as we looked at this formula. I will be from the rightmost, right? So this line will not be actually required. What we're finding here is the position. So the position will be n minus 1. Okay, this will be the position from the left, and so finding out the position. Okay, this will be the position of the child. Then we can just go ahead and print this value. And if I save this and I print all of this, you can see all the test cases are passed. Let me just go ahead and submit this solution as well so that you guys know it works. You can see the solution passed. I hope you're able to understand how we're doing this problem, how we're breaking it down. Maybe the explanation was a bit too big, but I hope you're able to get something out of this. If you have any doubts, let me know down in the comments. I'll see you in another video. Thank you so much for watching. If this video helped you, hit that like button. Bye.